So as you can see that I've written here, a relation is any set of points that connect two variables. And I've drawn two graphs that are relations. So this one is kind of a parabola flipped on its side where the x and y values are reversed. And this is a set of points that connect two variables, so this is a relation. And so is the second graph. Just a bunch of random points that connect the x and y values. There's no specific pattern for this, and it's not a line, but this is still a relation. A relation doesn't need to be a pattern or have like a continuous line of points. It can just be something like this. And a function is a type of relation where any 2 points will not have the same x value. And another way to describe it is no 2 points or no x value will correspond to 2 different y values. So this first graph that I've drawn here, if we take like x equals 1 right here, it corresponds to 2 y values. So this is not a function, but it is a relation. But for the second graph, just these bunch of points, if we assume that each point has a different x value, like none of them have the same x value or anything, then this would be a function because each point corresponds to a different y value and a different x value. And functions, if they have the same y value but a different x value, then it still would work. Like say if these 2 points were both y equals 2, then it would still be a function because they have the 2 different x values. To figure out if a relation is a function, you can either look at the equation or look at the graph. And if you look at the equation, you can look at the variables and the numbers and everything to make sure if it's a function or if it's just a relation. So, looking at this first relation, just by using logic and common sense, we can just figure out this one is a function. There's nothing tricky going on here. This is just a regular linear expression where every x value corresponds to one y value. But the second relation is a little more tricky because we have an operation on the y, which we don't normally see. And this one is not a function because if x is positive, say x is 4, then y can be two things. Obviously, y can be 2 because 2 squared is equal to 4, but it can also be negative 2 because negative 2 squared is also equal to 4. So this one is not a function. And if you look at the graph, you can perform something called the vertical line test, where you imagine every single possible vertical line drawn on the graph, and then you check if any of the vertical lines touch the points on the graph more than once. And if they do touch the graph more than once, then it is not a function. So for example, for this one, if we draw the vertical line anywhere, like right here, it touches the graph more than once. One here and one here, which is twice. So this graph is not a function, it's just a relation. However, for the second graph, no matter where we draw the vertical line, it's only going to touch the graph once. So if we draw the line here, only touches it once, and there's no place where it can touch it twice, so this graph is a function. Now, let's look at these sets of ordered pairs and let's figure out if they're functions or not. And these are all relations because they're relating one variable to another, x and y. So let's just look at the first one first. The points are 1, 3, 2, 4, 3, 5, and 4, 6. And for these, we can just kind of ignore the y values and look at the x values. So we have 1, 2, 3, and 4 for the x values, and none of them are the same, so this one is a function. Now let's look at the second one. The points are 1, 3, 3, 2, 1, 7, and negative 1, 4. And for this one, the x values are 1, 3, 1, and negative 1. And we can notice that there are 2 points with the x value of 1, 1, 3, and 1, 7. So this one is not a function because a function will not have 2 points with the same x coordinate. And let's look at the last one. 7, 6, 3, 6, 5, 6, and negative 4, 6. And the x values are 7, 3, 5, and negative 4. And you may have noticed that all the y values are the same, 6, 6, 6, and 6. But this doesn't really matter. All we need to focus on are the x values. And since they are all different, this one is a function as well. Now, let's get into some practice problems. If you think you know how to do these problems, then pause the video and do it. But this question is asking to determine if the following relations are functions. So in order to be a function, they need to be relations first, which we are already given by the question, and it needs to pass the vertical line test, which we've discussed before. And all of these are graphs, so we can easily do the vertical line test. Now let's do this first one here. And we're given kind of like two parts to the graph, one here and one here. And the vertical line test, both of these individual parts will pass it, but we need to figure out if both of these parts will touch the same x value. We can see that these lines both approach 0, but they won't touch it. So no matter where we draw it, even if we draw the line at 0, like right here, it will not touch both of the lines, or the halves, I guess. If we draw it here, it only touches it once. If we draw it here, it only touches it once right here. So this is a function. However, the second graph is a circle, and this is pretty obvious. If we just draw a line like down the middle right here, then it touches right here and right here, which does not pass the vertical line test, so this is not a function. And this one is a little bit more tricky. Now, if you don't know, these empty circles represent like they don't touch that point, and the filled in circles means that the point is there. So this line means that everything between these 2 points exists, but they don't touch the 2 points. So all these lines individually, they pass the vertical line test, but do they ever have the same x value? The only places where they get close is here, or I guess like here to here, here to here, and here to here. Everywhere else is kind of like obvious that it does pass the vertical line test. Now, if we notice here, each of these have a filled in circle and an empty circle, which means that only one place actually exists. The other place is not actually a point, so all these pass the vertical line test, which means that this is also a function. Now, let's do another practice problem. If you think you know how to do this one, then pause the video and try it. This problem states, is x squared plus y squared equals 9 a function? And it may seem a little tricky at first, but if you think about it, it's not that hard. So first, let's isolate y squared by bringing the x squared to the other side. So y squared equals 9 minus x squared. And I can notice that if the right side is positive, then y has two different possible values. So this right side cannot be positive at all if it needs to be a function. So for example, if the right side like hypothetically equaled 16, then y could equal to positive or negative 4, because 4 squared is 16 and negative 4 is also 16. However, if x squared is 3 or less, then y squared, or the right side, is positive. For example, if x was 2, then we would get 9 minus 2 squared is equal to 5, so y equals positive or negative square root of 5. So it is not a function. And if x is more than 3, it will only correspond to one y value, but since some x values correspond to 2 y values or more, well, in this case it's just 2, then this is not a function because it does not pass the vertical line test for all x values. So everything that I explained in this video and all the problems that I went through should teach you everything that you need to know about relations and functions and how to differentiate between them. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.